Okay, cool. All right. So I guess first of all, thank you everyone for joining us on this talk on the serverless security and for joining us on the LessCon as well. So I guess one of the first things that you notice when you go into AWS is that you've got this shared responsibility model where AWS tells you what they are responsible for security-wise and what you are responsible for. And one of the things that's different when it comes to doing serverless on AWS is that now AWS is taking over more responsibilities. So the security of the operating system, the networking, the firewall, and all of that becomes a part of their core competency, which is great. It means that usually that means that you can get a better protection from any attacks against the operating system, because application developers like myself just not very good at being very I guess a discipline and constantly keeping the operating system up to date, patching all the AMIs and things like that. It means that we are better protected from attacks such as WannaCry or the likes of Spectre, Meltdown. In fact, when those two vulnerabilities was announced, I remember spending a couple of days just patching all the Docker images we had or the AMIs we had, but then we weren't even thinking about our Lambda functions. And at that point, I saw a tweet from Chris Munns and said that all the infrastructure that are running Lambda and Fargate has been patched against the Meltdown and the Spectre. And that's when it hit me that, oh, we weren't even thinking about Lambda functions, and that's one of the benefits you get by having someone like AWS taking care of the security of your operating system. That said, there are still a lot of things that are left for us to secure and manage, including all of our own dependencies, but also dependencies of our own dependencies as well. So if you look at the OWASP top 10, the current one is still from 2017. I think there's one now being looked at for 2020. And compare that to the OWASP top 10 from 2010 and 2013, which is the top 10 security risk facing web applications. You can see that very little has actually changed in over many years. And when the Guy Pajani from Sneak and his guys looked at some of the top vulnerabilities, top data breaches that happened a few years ago, they found that something like a quarter of the top 50 data breaches happened because applications were using components with known vulnerabilities, and that a lot of websites, something like 77% of the top 5,000 Alexa websites were using JavaScript with known vulnerabilities as well. And it's not hard to actually understand to see why that's the case, because even some of the biggest libraries out there like React and Angular and jQuery, at some point they've had vulnerabilities in a particular version. Of course, those vulnerabilities was patched, but then it's up to you to make sure that you're upgrading your dependencies, to make sure that you're running on latest versions where you have those security patches. And for example, if you are parsing user agent and using the user agent, the library, then at some point it also had a regex denial of service attack vulnerability as well, where someone can execute a really long a string which almost matches your regex but doesn't quite, which forces you to constantly backtracking, and then it takes you a long time to compute. So if you're using a Lambda function and you're using user agent library to parse the user agent header, then you will be vulnerable to this vulnerability as well. And of course, if you're using SQL databases from Lambda function, then you are also vulnerable to any SQL injection attacks as well, as comically illustrated by this SKCD comic. And it turns out even when you're using NoSQL databases such as MongoDB, it's also potentially possible for attackers to execute injection attacks against them as well. For example, MongoDB's query API has a small vulnerability where someone can execute code to extract data that you don't intend to return. I haven't seen anything along this particular attack vector for DynamoDB yet, and I think DynamoDB's APIs does make it a lot harder to do something like this, but potentially you are still vulnerable to other types of attacks such as cross-site scripting and so on. And I guess if you're using Any sort of relational database, you want to make sure that you're using prepare statements, and also you want to sanitize the user inputs. But also, if you are passing the output from one function to something else, potentially where you're handing off events through SNS, EventBridge, or other, or dropping files into S3 and trigger other functions to process things, then you also want to sanitize your output as well. And this is also very relevant to where you're building user-facing APIs, where potentially someone is able to execute some kind of injection attack and run queries and try to return data you don't intend to. And so having some sanitization in place against your own output helps you stop those data from being leaked where you're not intending to return them. So I think I forgot who said this now, but I think this makes a lot of sense, that security is as much about what your functions should do as well as what it shouldn't do. And this is where you want to be careful and filter out data that you shouldn't ever return from your function. And recently I've been working with GraphQL quite a bit with AppSync, and you probably have heard a lot about GraphQL. It's been gaining a lot of popularity over the years. And turns out, when I was doing some research, it's also possible to execute injection attacks against GraphQL endpoints, especially when your GraphQL server just translates those queries into, say, standard SQL query, and you're not doing sanitization against the user input. Then you can potentially also be vulnerable to injection attacks, even if you're using GraphQL as instead of REST. There's also other vulnerabilities I've come across in this area, using JavaScript libraries that uses under the hood uses the JavaScript's eval, which is evil, and of course, if you're using them in your Lambda function, you will also be vulnerable as well. So I guess the moral of the story is that you want to update your dependencies regularly to patch any known issues. However, there's often this, this trade-off there, where when you update into new versions of libraries, sometimes you get other bugs instead. So it's not quite as easy and straightforward as it is to sometimes apply OS level patches. So my name is Yan Cui. I'm, as Tao mentioned, I'm an AWS Serverless hero, and I've been a long-time user of AWS as well. I've been running production workload on AWS for over 10 years now. The last couple of years, I've focused on the serverless space, including migrating a social network to run pretty much entirely on serverless. Nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo is a troubleshooting platform for serverless applications where you have a single place to go to see all of your logs and your traces. You can see them side by side as well. And the other half of my time, I spend working as an independent consultant, where I work with customers directly to try to help them go faster by adopting serverless technologies, by providing them with training, advice, and sometimes working with the customer to deliver a new product. And also got a couple of books and video courses with Manning, and also self-published a couple of video courses as well. And recently, I've also started a podcast called The Real World Serverless, where I speak with other people that are building stuff in production with serverless technologies. So continuing on from where we left off there, we were talking about application dependencies. And I think the story here really is that your application dependencies is probably a much bigger attack surface than you realize. There's the things that you depend on directly, but then oftentimes you find that the libraries that you depend on have their own dependencies as well. In fact, it's not hard to pick up any number of mainstream languages and the popular libraries in those languages to find that there's a very deeply nested list of dependencies in terms of packages. And in fact, when it comes to Node.js, it's such a well-known thing that even if you just have one dependency, you look into your Node modules folder, you see thousands and thousands of folders and dependencies in there. And of course, trying to manually patch all of your dependencies constantly is just not going to happen. It's just too much work. That's why using services like Sneak is really, really useful, which helps you update those dependencies for you. And they have built-in integration with Lambda as well. But however, the thing I found with in terms of updating my application dependencies that's quite different from updating my OS and applying OS patches is that whereas the OS patches are usually self-contained and is issued by a trusted entity like Microsoft or Apple, with your application dependencies, they often come with other feature changes or API changes. That means you need to reintegrate with them. You need to test your application to make sure everything is still working, and that sometimes can cause incompatibility between your different projects as well. So if you've got different, say you've got a micro front end and you've got different versions of React, for example, that may cause problems when you integrate everything together. And not to forget that the sort of weakest part of your security chain is still so your security is only as good as its weakest link. And when you look at all the different places someone can potentially attack your serverless application, there's the physical infrastructure that's supported and maintained and secured by AWS, and then there's your application code, there's your dependencies for your application. In the movies, of course, people are gonna just go to the physical infrastructure and try to attack those. They're gonna hang themselves down the wires and then log into applications that they never seen before. But in the real world, there are just so many low-hanging fruits that you can execute attacks against someone's application. Often using things like injection attacks, cross-site scripting, or trying to exploit known vulnerabilities in their dependencies. And of course, people are often the weakest part of any kind of security chain. If you haven't watched the Mr. Robot, you should definitely go and watch it. Just binge watch the whole thing. It's amazing. But one thing you notice is that most of the hacks that the characters do in the TV series is around social engineering. It's around phishing and targeting the users of a system. And of course, when it comes to our application, there's also the developers for the application. Maybe if someone haven't taken the care to secure their GitHub account properly, and an attacker can potentially get into the application's source code by compromising one of the developers' GitHub accounts. And also, it turns out there's another group of people that are part of our security chain, which can also be exploited, who are the authors of the NPM packages that we depend on. So this happened in 2017, where a white-hat security researcher managed to gain published access to something like 14% of all NPM packages that's available on NPM at that time, which included some of the most popular packages out there like Express, React, Debug, and Electron, and so on. All in all, those packages accounted for over 20% of the total monthly downloads from NPM. So that's a pretty crazy number. That's 1 in 5 packages that you have downloaded could potentially have been compromised because the authors of those packages haven't taken care of securing the NPM account. And when you look into what the researcher actually did in terms of how did he manage to get all that published access, he didn't do anything crazy. He wasn't particularly certificated. In fact, he was using mostly known account leaks from other places, and sometimes in some cases he found that the people's NPM credentials was in plain text in the public GitHub accounts. And so he combined some of these known account leaks with some random generation of characters at the end and to suffixes, and able to get access to 14% of all NPM packages. And when you look at the summary, it also doesn't make for a pretty reading, where something like 1,000 up to almost 1,000 developers was using passwords like 123, 123456 and password for the NPM account. So clearly we know to do better, and clearly we can do better. And this is just a problem with attitude that maybe we just often don't think about certain things like GitHub accounts, things like NPM accounts. And for Lambda function, there's a very interesting implication here, where if our dependencies are compromised, because when you look at the execution environment for any Lambda function, you find some really useful information that an attacker will find very tasty in terms of your AWS Assets key and the secret key, session token, and region. Basically everything. All the information an attacker needs to be able to assume the identity of your Lambda function and access your AWS resources. So to see how easy this can actually be done, I published an NPM package called the "Do Not Download This Package," so where I try to sort of simulate this kind of attack vector, and I clearly, I don't want people to download this, so I gave it a really noticeable name. But to my surprise, within the first week, I had over 200 downloads, which I guess clearly tells you something's not quite right here. So with this package, all I'm doing is I am taking your environment variables and sending it to some backend. Of course, I was really paranoid that someone would actually install this package. So what I did in the end was I had a trigger there as well. So only if so this code will only run if there's some specific conditions that are met. So I set up an endpoint whereby I am collecting those environment variables, and then I'm looking for things I'm interested in this case, AWS credentials, and then when I find one, then I publish to SNS topic, which in turn send myself an email so I can then grab this and then put it into my console to see whether or not I can actually use these AWS credentials. And lo and behold, yep, I was able to use the credentials to access my AWS account, use and list my S3 buckets, and that took me about 5-10 minutes to actually put together. So this kind of attacks is really easy to orchestrate. And also wanted to test whether or not this is whether the same thing can work for transient dependencies. So again, set it in the package, and again, people downloaded the package straight away, which is really scary that this happens. And of course, still works when you have transient dependencies as well. So not so great, not doing well so far. And turns out there's I was going about this the wrong way. I was going about this the long way around. Turns out there's actually other way that you can attack you can attack the people. You don't even have to compromise legitimate packages. So this happened also in 2017, whereby an attacker who probably wasn't even trying to hide what he's trying to do, basically published a bunch of npm packages that has got a similar name to real ones. So instead of cross-env, he will publish a package called cross_env, and then someone will accidentally install the wrong package. And in this case, he was stealing people's environment variables, because again, oftentimes we find ourselves putting sensitive data in the environment variables in plain text. And I see people do that with Lambda functions, as well as with containers and so on. Turns out with npm install, there's also other things that can potentially be done as well in terms of npm install scripts. So there's also other things that people can do against to your laptop. So it all makes things a little bit scary. And turns out these kind of attacks is not just hypothetical. These kind of attacks happens all the time. And I'm sure Tao can tell you a lot more about the kind of attacks that actually happens in the real world against different ecosystems. Another thing about npm, I know I'm kind of picking on JavaScript here because that's the language I work with the most nowadays, is that if you look at when you install a new package, you see this little caret sign. It means that when you run the next time you run npm install, it's going to install not the specific version you had there, but the latest but still compatible version. So where I install version 1.0.0, the next time you run npm install, you might actually install 1.1.0 or 1.0.1, which means in between, say, committing my code and testing it locally, and then actually getting deployed, because you're going to be doing a clean install on a CI server, you can potentially install a slightly different version to what you had tested locally on doing your test when you were writing the code. So in this case, potentially, if your package was compromised and then you just happen to be unlucky, and then when you did a clean install on a CI server, you could have installed a slightly different version, one that might be compromised instead without you even noticing. So one of the things you could do in this particular case is that instead of using npm install in the CI environment, run npm CI instead, whereby nowadays with npm, whenever you install a package, it would create a package log.json file. But annoyingly, when you run npm install, it just disregards whatever's in the package log file, and will try to install the latest version. So when you use npm CI instead, it does respect the version that you have in the package log file. So this is how you can get the repeatable builds as well. And of course, this kind of problems is not specific to Node.js or npm. It's just happen to be the ecosystem that I'm most familiar with nowadays. But it also happens against the .NET and Java or JVM world as well. So what happens now is that the attacker somehow managed to get into your systems, maybe through your dependencies or some other way. So the next line of defense that we have is using IAMs to control basically who can invoke your function, but also importantly in this particular context, what can your function access. And this is where the principle of least privilege is your best friend. And it's basically it means exactly what it says on the tin in terms of basically restricting your functions to access to have the least amount of permissions and privilege it needs to do its job. And the same applies to networking side of things as well. So one common mistake I see people make is that they think, okay, right, I've got everything inside a private VPC and public VPC for things that are public facing, and I'm using VPC peering so that you can the stuff that's in the public VPC can talk to the resources that are in the private VPC. And usually you've got this thing whereby everything that's inside the public everything that's inside VPC is fully trusted. But in this case, imagine if an attacker is able to execute some kind of injection attack and can potentially steal information from your application, or maybe in this, like we discussed, potentially it's not your application that's compromised, but one of its dependencies, in which case attackers can steal data from your application, even though it's protected and sitting inside a VPC. In fact, I think nowadays we're seeing more and more cases where AWS credentials are being stolen and used to do Bitcoin mining. And we'll talk a bit more about that a bit later on. There's some certain things you can do to help really mitigate or at least reduce the risk of Bitcoin jacking. I forgot the name of that, but I think it's something like Bitcoin jacking or something like that. So when you consider that AWS services like Lambda, DynamoDB, they're always publicly accessible, but you can control access through IAM. So in this case, even if it's public and not sitting in one of your VPCs, it's still nice and secure. However, the same risk that we discussed still exists there, whereby our application can be compromised through its dependencies. So this is where Prisma Cloud from a Palo Alto network, but also I'm sure Checkpoint has got similar offerings as well, whereby they have some runtime component that can block those attempts to communicate with public internet. So if someone have compromise your application through maybe one of the dependencies and try to steal your AWS credentials, then those runtime protection can stop those communications from going out, from leaving your function and going to attackers' malicious endpoints. You can also achieve similar things using VPC and using network ACLs and things like that. But of course, those takes a lot more effort for you to actually set up and maintain and keep up to date. So if you have EC2 instances or ECS containers that are sitting inside your VPC, and if they're compromised, then they can still allow attackers to access all the sensitive data you have, all the in your AWS resources that are sitting within your VPCs. Which is why a much better way to approach security for your application is what is nowadays called the zero trust networking. Essentially, for every single API you have, you want to implement authentication and authorization. So basically, trust no one with whether or not they are sitting within your sort of trusted network environment or not. Just don't trust anybody. Always implement authentication. So very commonly, we will create the APIs using API Gateway and the Lambda. And the common question I get is, well, API Gateway supports all these different authentication methods. Just what should I use for my application? So I wrote a blog post recently to walk through the different options you have. Essentially, I think if you're building some kind of a SaaS application where you want to give access to some other third party, but you want to also at the same time rate limit them as well, then you should be using API keys together with the usage plans. But if your API is going to be used by end users directly, then if you're using Cognito, then you should use a Cognito authorizer as the authentication method. Otherwise, you can also use a custom Lambda authorizer function to integrate with other user management services like Auth0 and things like that as well. Alternatively, you can still use Cognito authorizer, but integrate Auth0 or Okta or other providers with Cognito through SAML. And for internal APIs, APIs that are only supposed to be accessed by your own services or other components like EC2 instances or ECS containers, then you should be using AWS IAM instead. And the thing that you probably shouldn't do is you shouldn't try to do authentication and authorization within the Lambda function itself, because in this case, if an unauthorized request comes through, it's going to go through API gateway and then it's going to go through to your Lambda function. And in this case, only at the Lambda function then do you realize, oh, this is an invalid request, we should reject it. And in that case, you can end up paying for the API request for API gateway as well as for the invocation for Lambda functions as well. Whereas if you're using one of the authentication, one of the authentication and authorization methods available for API gateway, and you can reject requests at API gateway level, then you won't have to pay for those unauthorized or invalid requests. So another thing you got to look at is in terms of applying the principles of least privilege is minimizing what your functions can access. And a key part of this is making sure that you have tailored role for every single function. So if you've got an API with lots of different endpoints and every endpoint is handled by a single Lambda function, then those functions potentially going to be doing different things. Some may need to read from a DB tables, other may need to do a write. So every function should have its own IAM role and that are tailored to just what that function needs to do. So depending on the deployment framework you're using, the server framework, for example, doesn't support this really well out of the box, but there are plugins like the Serverless IAM roles per function plugin that basically you do exactly that, whereby for individual functions you can configure what IAM permissions that function would have. Of course, the downside of this approach is that it does take a lot of developer discipline, and we know that if you need to depend on developer discipline, then you are going to fail, and we need tools that can automate a lot of this for you. And again, this is where providers like PureSec and Protego comes in, and both of them has been acquired, as Tao mentioned just now, that the Protego been acquired by Checkpoint, and PureSec has been acquired by Palo Alto Network. Both of them provide the services and the tooling that can automate some of this for you. Another thing that you often hear about is that when you're writing Lambda functions, they should be ephemeral, they should be stateless, which does mean that you end up using a lot of different services, external services, to keep hold of a user state. And it's important to make sure that those data are secured and encrypted at rest as well as in transit. The good news is that pretty much all the AWS services that handle user data now support server-side encryption. So this started with S3, with S3 server-side encryption. There's a couple of different options you have there, and RDS supports that now as well. And so there's RDS, DynamDB, and the QLDB supports server-side encryption as well. And again, you also so you want to do all of that, but still want to make sure that you allow your function the least amount of access possible, which is a very, very key part of securing a service application. So, and one benefit of using Lambda is that you don't pay for functions that are just that you don't use. But it also means, on the flip side, it also means that sometimes it just less incentive to delete old functions that are no longer used, which potentially leaves functions that are out there that are sort of old and using old versions of dependencies that are not being maintained actively, sitting around in your environment, potentially still presenting themselves as an attack surface. So as part of the sort of best practices that's recommended by AWS, they do ask you to delete old versions of your functions or old functions that you no longer use. What I find is that in practice, this is a lot easier said than done, especially in a large IT organization, whereby identifying ownership for different components is quite challenging. But when it comes to having individual functions, that's even more difficult, especially when it comes to time to figure out whether or not function is actually being still required, or is it just not being used actively because it's only used for disaster recovery scenarios, or using for fallback cases for dealing with failures that just doesn't happen often. So one of the things that I find really helps in terms of helping you identify ownership really quickly and easily is that every function should get tagged with a number of useful tags, such as the name of the team, maybe the cost center, which really helps you in terms of cost tracking as well, but also maybe the business area or the name of the author as well, if it's owned by a specific individual within your team. And then there's also this whole thing around the service attacks with Lambda functions. With serverless, you're more likely to survive the service attack because the system is just more scalable by default. However, you do end up paying for them. So which is why often nowadays we call denial service attacks in the service world denial avoided attacks, because well, you may be able to scale force your way through that, but you end up paying through the nose for those attacks, which is why it's still important for you to use things like a WAF and configure them on API gateway or on the cloud front. And specifically, you want to use set up rules for RAID-based rules against single IPs. These are useful and effective against naive attacks that originate from a single IP address, but they're not effective against the distributed attacks that come from many APIs, IP addresses. Which is why, on top of that, you still want to set up a throttling on API gateway, which is enabled by default for REST APIs, but not for HTTP APIs. So however, with REST APIs, one thing to keep in mind is that you want to review the default setting, because the default setting for API gateway REST APIs is 10,000 requests per second, which is way more than most API endpoints needs to handle. And also the 10,000 requests per second, that's also your regional limit, which means potentially as an attacker, all I need to do is launch an attack against a single endpoint, a single publicly accessible endpoint, and I can potentially take down all of your APIs in the entire region, because the default throttling limit on API gateway is also your regional limit as well. In terms of protection against the denial of service attacks, AWS has got a few other things in up their sleeve. There's AWS Shield, which protects against the network layer flooding attacks and things like that, and it's available to everybody, just for free out of the box. But if you want more protection against that, then there's also AWS Shield Advanced, which very usefully, it gives you access to a specialized team within AWS, so that if you are under attack, then you can reach out to this team to help you, walk you through how to mitigate that attack. And also it's got some protection against the extra charges that you incur for things like ELBs, CloudFront, and Route 53. But unfortunately, that protection doesn't cover things like API gateway and Lambda costs. So one of the things that you also want to think about when it comes to protecting your Lambda functions is that you don't want to have because you're paying for Lambda invocation, but also for the duration of a function as well. So in cases where your function potentially are under attack, or maybe you are being say someone is executing a regex now service attack, then the potential can cause your function to run for a very long time. So every single request ends up taking longer and therefore cost you more. So one of the things you can do to protect yourself there is just be sensible when it comes to applying your timeout for your function. Don't just throw 5 minutes or 15 minutes on every single function. For API functions, for example, API gateway has got a hard timeout or integration of 29 seconds anyway. So even if your function runs for a whole minute, it doesn't really matter, because API gateway will have timed out by then. And so for API endpoints, typically you want to use a really low timeout, like 3 or 6 seconds. And also make sure that you've got a good alerting setup, so that when there's a high number of 4xx or 5xx errors, make sure that you get alerted quickly so that you can investigate what a problem is. So I touched on the Bitcoin and how people are now trying to steal your AWS credentials so that they can do Bitcoin mining on your AWS account. Right, the name I'm looking for is cryptojacking. That's what it's called nowadays. And it's not hard for you to find lots of articles on the internet of people and developers like you and me who has been hit by this, whereas maybe you just accidentally put your AWS credentials into a public GitHub repo, push a commit without realizing, and then bad things happen, and next thing you know, you wake up and you got a massive AWS bill because someone has used your credentials to do Bitcoin mining. So when I was investigating how to sort of mitigate this specific attack vector, I found that there's a really good way to do this is using git pre-commit hooks, and then basically run a script and trying to find out anywhere that you have plain text that looks like AWS credentials. Another thing I heard from my contacts within AWS is that when this kind of cryptojacking happens, Sao Paulo and I think Tokyo and a few other regions are the hotbeds for attackers to launch EC2 instances, because for many people running on AWS, they are not using those regions. So when the attackers create EC2 instances in those regions, chances are you won't notice. So something you could do is you can monitor those activities in regions that you're not using CloudWatch events, and you can also have CloudWatch events or EventBridge in this case. Basically, it's got rebranded to collect all these different events from different accounts, so that you have one single account where you can set up this kind of monitoring. And if you got this multi-account setup, in fact, an even better way to do this is to just disable those regions in the first place. So if you're using AWS organizations, then you can set up service control policies or SCPs, in which case you can disable access to specific regions or even specific services within those regions. And one of the best tools I've found to manage this, especially if you want to use infrastructure as code, is this open source project called AWS Organization Formation. Essentially, it's extension. Well, not extension. It's a tool that basically allows you to use CloudFormation-like syntax to provision and manage your entire AWS organization, including configuring service control policies like what I have here, whereby I know for this project I'm only using US East 1, so I'm just going to disable all the other regions except US East 1, except for a few services that are global, like CloudFront, IAM, and Route 53, and so on. So I actually did a webinar on this with the creator of the org formation recently, so you can go and watch it on the YouTube afterwards. And the last thing I want to touch on in terms of some of the things you want to think about and to secure your serverless application is using this concept of a bulkhead, which is used by ship makers to compartmentalize a whole breach, so that if one part of the ship has had a breach, then it doesn't take down the entire ship. And this concept has been popularized in the microservices world by Michael Nygaard in his book Release It. So in terms of bulkheads, there's several things we could do. We can apply least privilege principle coupled with having per function policy, so that if one function gets compromised, because every function's got its own IAM role, so again, you're compartmentalizing that breach to just what that one function is allowed to do. But again, also you can apply that to the whole AWS account as well, whereby if you have multiple AWS accounts and somehow someone got access to your dev account, at least they won't have access to your production accounts, the user data, which again is a good reason for you to have separate accounts for different environments. And that kind of covers everything I wanted to cover with this talk today. As a quick recap, it just goes through some of the things we've covered already. Think about your application dependency is probably a much bigger attack surface than you realize, and that the risk from OWASP top 10 is still very much applicable when it comes to the security of your serverless application. And wherever possible, you want to sanitize your user inputs, but also sanitize your outputs as well, so that you don't leak data that your application shouldn't return. In terms of the soft security of your Lambda functions, apply the principle of least privilege and give every single function its own IAM role and tailor that permission to just what that function needs to do. And don't forget, you got lots of data spread out in different data services, and you want to encrypt them at rest, but also encrypt them in transit as well. And when you have Lambda functions that aren't being used, delete them proactively. And nowadays, remember, denial of service attacks is still a thing, it's still a problem, because it can cause us problems in terms of our AWS account, how much we pay. The AWS Shield, however, it doesn't cover the cost for Lambda functions. And also, take care of your AWS credentials. You don't want to be a victim of cryptojacking, end up with a big bill for AWS accounts, and then have to find some way to get those money back. And finally, compartmentalize your environments using separate AWS accounts. And remember, people are still the weakest part of any security chain. So if you want to learn more about AWS Lambda, just also check out my video course as well, lambdabestpractice.com, and I'm available as a consultant. So if you want to talk to me and see how we can work together, check out my services at theburningman.com. And with that, thank you guys so much for your time, and stay safe. And I guess we would take some questions now.